Hello everyone. In this video, I'm going to discuss solution of a mathematics question. This was actually sent to me by a student yesterday. In this question, actually, maximum value of function has been asked. So this function is written in somewhat tricky manner. You see, the function is present here. It is also present here. Okay. So this type of equation is called self-consistent equation. Okay. So let's see how it goes. देखिए फंक्शन यहाँ पे इस फंक्शन में इंटीग्रेशन जो है वो t वेरिएबल पे है इंटीग्रेशन इज ऑन वेरिएबल t एंड सो वंस वी डू इंटीग्रेशन ऑन t विल नॉट बी देयर t यहाँ पे से खत्म हो जाएगा तो सिर्फ x बच जाएगा सो दैट्स व्हाई दिस हैज बीन रिटन एज अ फंक्शन ऑफ x ओके व्हाट आई एम गोइंग टू डू इज आई विल रीराइट दिस फंक्शन इन दिस वे y of x is equal to see sin x is present in two places so I'll take sin x common. ठीक है sin x multiplied by you will get here 1 if you take sin x common and here you will get minus pi by 2 to plus pi by 2 ठीक है and here you get pi of t and dt ठीक है this term comes here plus so this we get and then we have cos x see this term actually depends on x it doesn't depend on t so it can be taken outside and here we get t and phi of t and dt and this integration is from minus pi by 2 to plus pi by 2 ठीक है तो देखिए once you do this integration okay there won't remain any variable here so this is just a constant so I'll call it constant a and similarly this integration is also a constant so this will be another constant b so this integration phi of x becomes a this is a so a sin x plus this is b so b cos x let us call it equation number 1 okay now we want to evaluate this a and b so here a is actually you see integrate it is 1 plus sorry it is 1 plus this integration minus pi by 2 to plus pi by 2 and this function so actually जो integration variable होता है that is a dummy variable okay so in place of t you can write x here okay you can write like this dx ठीक है so this we have written in place of a okay now you see phi of x we have written a sin x plus b cos x so we'll write like this 1 plus integration a cos x or plus b a sin x था है ना so it is a sin x plus b cos x and we get here dx this is minus pi by 2 to plus pi by 2 okay so that's what we have now you see this sin function is odd function so its integration will give you 0 when you take limit minus pi by 2 to plus pi by 2 and cos integration sin दे देगा ठीक है ना sin and sin pi by 2 is 1 and this minus pi by 2 minus 1 so basically this will give you 2 okay so we get here a is equal to 1 plus and there is b term and this integration gives you 2 so a plus 2b so this is our second equation this is first equation okay now let's evaluate this constant b so b is equal to we have b is equal to t and integration phi of t and dt so again what I'll do is in place of t I'll write x everywhere okay so this is x and dx this is minus pi by 2 से plus pi by 2 okay because t is a dummy variable in place of t we can write x okay now you see integration variable is actually called a dummy variable you can write you can change that variable if you want okay so this is minus pi by 2 to plus pi by 2 plus pi this is pi by 2 actually pi by 2 and here x and in place of phi x we can again write a sin x or plus b cos x okay and dx okay now again we have to do this integration so cos function multiplied by x is an odd function so its integration from negative to positive limit will be 0 so this function only remains okay so here we get b is equal to this a will come outside and we get here a sin x and dx ठीक है limit है minus so we can write this limit क्योंकि ये even function है so we can write it as 0 to pi by 2 and multiply by 2 okay so if you do this integration by parts I think you will get 2 okay oh 1 I guess this integration will give you 1 okay so we get here 2a so we have obtained b is equal to 2a this is our third equation so let's solve second and third equation solve second and third So if we solve second and third, see we have gotten a equal to 1 plus 2 times, so in place of b I'll write 2a. Okay, so this becomes 4a. Okay, so from here you get minus 3a is equal to 1, so a is equal to minus 1 by 3. Okay, so you can put that here. So therefore you get b is equal to minus 2 by 3. Okay, you put the value of a. So we have gotten the value of a and b. So let's put that in equation 1. Okay, so you get here phi of x is equal to minus 1 by 3, and here this becomes sin x of plus twice of cos x. Okay, that's what we get. So this is a combination, linear combination of sine and cosine function. Okay, so what I'll do is I'll combine this sine and cosine function. Okay, what I'm going to do is I'll here this is minus 1 by 3, and here I'm going to write some a sine, मतलब यहाँ पे जैसे 1 coefficient 1 है ना, so I'll put this 1 is equal to say some a cos theta, और यहाँ पे जो 2 है उसकी जगह पे हम लिख देंगे a sin theta. So if you square and add the 2, okay, you will get a equal to root 5. Okay, sin square plus cosine square will become 1. Okay, and if you divide the 2, you will get tan theta is equal to 2. So therefore theta is equal to, you will get tan inverse 2. Okay, so these substitutions we are going to do. Okay, so in place of a I'll write root 5, and then here, so it will become root 5 will come outside. So basically I'm substituting in place of a root 5 cos theta. So it will become like this, sin x or into cos theta plus, here you will get in place of 2 you will write a, in place of a you will put root 5, so you will get here root 5, okay, and sin theta. Okay, so you have already cos x, oh sorry, in place of this 2 I'm substituting this root 5 and sin theta, so root 5 I have taken outside, so you get here cos x and sin theta. Okay, so now you see here minus root 5, we have gotten minus root 5 by 3, and this is sin x plus theta actually. Okay, sin x plus theta. So this is phi of x. Now you see, we know that the value of sine function varies from minus 1 to plus 1. Okay, so if we put here minus 1, we'll get maximum value. So therefore phi of x ka jo maximum value hai, its maximum value, okay, that will be equal to root 5 by 3. We'll put here minus 1. Okay, so that will give us root 5. So that is the maximum value of phi of x.